Alright. 8 o'clock, so I'm going to go ahead and get started. Alright, so what do you call an alligator in a vest? It's an investigator. Alright. I need to get started. So last time we got some movement and we got some of the scripting in. However, since the last time I streamed, I got a lot of stuff done within the OPengine. So I'm going to go ahead and make sure that we're building right first. Release mode for the engine. Alright, and we're going to build it. And we're going to start up Wayward. Few errors yet. Hello, Boo Robin. Alright. Just about done building. Building a game. It's called Wayward. It's supposed to be a game for parents to play with their kids. Alright, so we succeeded there. Let's go back to debug mode here, and so we're going to get a whole bunch of build errors here. Okay, so OPengine, so I renamed a whole bunch of stuff in the engine, making things a little bit more consistent all across the board. Create effect. Actually, it's effect create now. Much shorter. Thanks. Hopefully it'll turn out pretty well. It'll be pretty difficult to get the difficulty in that I want without making it too difficult for the kid or too difficult for or too easy for the parent. So most of these are just simple renames. P effect. And kind of inverts this. Almost there. Alright, let's see how that is. Few errors. Unresolved, scripting. Okay, so we gotta go back to the engine. We need to. No, the V8 engine is built in. Let's try that. 2. Alright, let's dig into this quick. Scripting issues. So it looks like okay, so I think I know what the issue is. I'm pretty sure it's because the scripting libraries aren't being included because of the recent changes that I made. So let's go into. Actually, we're going to open up Sublime. That'll make it a lot easier to dig into. So the engine is using CMake. And so some of these have changed around on how I implement them. So I'm pretty sure right here, add OPFX V8. So OPFX option V8 needs to be checked in order for it to add the libraries to it. I did not think about that. I'm going to go ahead and mark that down. Okay, so now what I'm going to do is I'm going to come in here and in the options, we're going to include these for now. Okay, so in the application of Wayward, so this is the engines repository. So we're going to go into CMake, or into Wayward's CMake. And right here, include engine options. What that'll do is it'll add all of these in here, and I can simply check it. Generate. And now Wayward is changed because of CMake, and so now it needs to rebuild everything. And lock. Yep, so that grabbed the V8 engine and grabbed the libraries. So now we're back to where we were. Let me grab my controllers. And we can make sure that we're still on par with what we were last stream. Controller 1. So we still got movement on that player. I'll plug in controller 2. And we still got movement there. Alright. So now we got movement on each of these. I want to try to add some more movement in. Make sure that the keyboard functionality is in. Let's see. So this is player 1, this is player 2. We're going to refactor these two in a minute. Don't need that. Oh yeah, so we got the scripting in too, the hot reloading, so let's test that out quick too. Solution Explorer, game script. So I should be able to just change this to a 1 for red. Yep, instant change, so that's still good. Alright. Come back in here and start getting some more input in. So this is if the player 1's gamepad is pushed down. So we're going to modify, actually let's see. Let's add another one. Let's move back to player 1 keyboard. We're going to say hold the keyboard. So if we have a keyboard key that is down, so OP key, we're going to use W. So as W is down, we want to increase in the Y. We're going to do times DT. Oh, that's interesting. We're multiplying elapsed twice here. That should significantly help. Okay, so in the X direction, we're going to use D. So in D, go to the right, whereas if we want to go to the left, we want to use A. So what we're going to do is these return integer values. So 1 for down, 0 for not. So if I do this minus the A key, then if the D key is not down and the A key is, it'll be 0 minus 1, so -1 times DT, which will push it to the left. Whereas if the D key is pressed down and the A key isn't, it'll be 1 minus 0, which is 1, so it'll push it to the right for the X. So we can do the same here for the Y, but use S instead. And that. Okay, now for the keyboard though, if we're looking at it straight down the axis, and we're trying to go to the right, and we try to go up at the same time, then we're going to be going a point that's way up here instead of the point that's kind of in that that unit circle. So to fix that, all you need to do is take a normal of that. Just normalize it. Not a normal. Normal is different. So back to norm. Okay. Okay, so now it's normalized, so it's never going to go past the unit circle of a 1. 1 is the absolute max in any one unit. And then 0.707 or something like that in the X and Y. Okay, so now we've got that. What we're going to do is we're going to do direction plus equals player 1's keyboard. So if no keys are pushed down, it'll just add 0. It won't do anything. And it's really fast and really slow on the gamepad. Why is that? Right, what is direction here? 0.002 dt. Okay, let's dig into this. Let's see for the axes for controller. So we're looking at player 1 axes. So I don't know why we had -1. Trying to decide why that was so much slower. Oh, you know, I was probably on player 2, wasn't I? Well, okay, that's slow. And that's fast. So somehow we're getting different values for the controller. Yeah, it's not... well... no, it is coming all the way up. Head Y, direction. Alright, let's pull these out and see what the values are on these and see why they're going so much slower. Player 1 X. Y. So 0, Y, that looks good. 2, I'm going to push it all the way up on the Y, so hopefully this equals 1. And it equals 1. So dt... 0.001. Direction equals 0.014, which is what we'd expect on the Y. So something must be different with our keyboard. So if you try to take the normal of a 0, 0, normalizing will take the length of a vector, but if it's a length of 0, it can't divide by 0, so it's going to return a vector of 0. So that's not an issue there. So let's go ahead and try and push on a key. So I'm going to push on the right. That's going to make it a little more difficult. Alright. So, player keyboard. What do we do? Okay. Let's try this. If keyboard W is down, just so then I can get a breakpoint in here. Alright, so W key is down. So Y equals 0.017. DT. Okay, so that makes sense. Our DT is good. And then when we normalize it, okay, so there we go. That's the issue. So we're multiplying the elapsed time and then normalizing it. We need to do it backwards. We need to normalize it and then add the elapsed time. So right now we're actually like increasing the elapsed time for the keyboard only. Let's go ahead and take that out. And then here, we can do times equals DT. That should make it a lot better. Yeah, much, much slower. So we could probably bump that up here. Much better. Let me go ahead and move the camera, that way it's a little bit more obvious. Right now it's kind of pointing at a top right kind of view. So, back 3, create, let's do, so on the 0, or on the X, we're going to go 0. Then we'll jump up 5 and jump backwards 5 units. And so that'll have us looking almost straight down at it. And that's a little easier to see. Okay, I'm pushing forward, pushing backwards, right, left. And then I can do the same on player or controller 1. That's a lot smoother because it's not like exact input. It's not an on or off thing. And then player 2, still good. Alright, so we got keyboard input again. Which that's always important to be able to use the escape key to exit. So we're good there. Alright, so the next step that I'd like to do is to try to pull some of this out into more of a batched system that can be reused. One sec here. Alright, so let's get back into the code a little bit further. And so now we're going to create a batched character system. Wayward, source, game. And so now we're going to call this character system. We regenerate the setup, the whole CMake system, it'll build the project better, or rebuild it. Now, so we're going to just call this character system. So now we want to create a struct for a character system that will build out any characters that we want, and then we want to be able to attach a controller to them. So rather than saying controller 1 goes to this character, we want to invert that and say this player, this character, has this controller. So first we're going to need, let's go ahead and look at our game system, what we have right now. So each player is going to need a position, and actually we want to move this a little bit different. We want to get into a physics-based approach with this instead. So we've got position, and we want to use a velocity and an acceleration. system. So what I want to do is I want to use a data-oriented approach to this, and that's the main reason to do a character system like this instead of creating individual characters in a list or something. This kind of inverts the problem, so then you can work on a whole bunch of the data all at once. Let's see if I can think about how I want to approach this. Alright, so we're going to create a character system entity, we'll say, and put this in here. Okay, so now our character system is going to have a list of entities with position, velocity, and acceleration. And then we're going to give it a gamepad controller. So now we need some methods to create the character system. Alright, so OPin to declare whether or not the character system was created correctly or not. Character system, and we're going to pass in a character system pointer. And we will pass in, actually you can use it. So OP is, if you see a capital OP in front of something, that means that it comes from the OP engine itself. And so a uint is just an unsigned integer in whichever system that you're in. So you could use a UI64, for example, would explicitly tell you that you're using a UI64. But if you use the OPUint, it'll go back and forth between a 32-bit and 64-bit, depending on the system. We're going to use a count. Oops. And then once we initialize this system, we're going to want to update the system and go through each one of these positions, velocities, and accelerations. So, your system update. And then we need a destroy. So we've got our character system included. We need to do a little bit of fill out here. I'd like to be able to tell the whole character system to render all of its characters as well. We're going to update it in one loop, and then we're going to render it in one loop. Character system. So this is assuming that you're passing in a pointer that's already been. So we're going to have a. So let me go ahead and just do it right here. Include in our game our character system. And then I can say that our game will have a character system. It's called characters. Here, so it's been zeroed out at this point. It's a character system init. Then I can pass in a pointer to the game data's character system. now we're going to say we only want two characters. We want player 1, we want player 2. So character system has a pointer to character system entities. So I need to allocate enough character system entities to fill this out. But I'm also going to need to know how many entities there are. So entity count is going to equal whatever we passed in. And then we need to allocate a set amount of entities, which are character system entities. Size of these times their count. Alright, so that'll allocate the entities. So now I should be able to build this. Nope. Oh, I must return values. Let's say that yes, that method succeeded, and this one succeeded as well. Alright, so we still got functionality. Now we need to go through and update these, and we actually need to get the render going. Alright, so we have positions already, but we want to update this so then we're using a velocity and acceleration scheme. So I'm going to go ahead and implement it loosely to start, just to make sure that we've got some functionality in it. But you know what? We're going to zero these out. So when we allocate it, it also does a B0 on the entire memory chunk that you allocate. That way all of these are going to be set to 0. And then controller will be null. So here, if I do if on this, so that means that it definitely succeeded. And really this shouldn't. If it does, then... Okay, we'll even do an assert on this. Success is... saying that we just, if it failed to succeed, success will be 0, and it'll it'll print the message out, failed to initialize the character system. And if it failed, it'll kill the program. That way we know for sure. So I can show that off. Success, 0. And if we step forward, it failed. And so if we've got the command line open, it'll show that. Otherwise, so I need a better way to do that in Visual Studio. I should just put a breakpoint in the engine to show that before it'll kill it off, or even just do a sleep. Alright, so we've initialized, we've made sure that it succeeded. And the next thing we want to do is we want to assign these gamepads to those. So we're going to grab these. Oops. Up here. So player 1 and player 2, if we access our game data characters and we go straight to the entities, we can say player 1, or the 0 entity, is going to have a controller of player 1. And we can even do this. And then the second entity will have player gamepad 2. Let's see. Okay, so if we've got gamepads on each of these, we should be able to move this. So our keyboard input is going to be a little bit different. We're going to have to rethink how that works to get that into the player, to assign a player a keyboard. And I'm not even sure if I want to do that yet, because really I want this game to be played on gamepads. Okay, so we're going to go through each of these. OPint I equals 0, I is less than the character system's entity count. So we're going to read through each one of them, and if it has a gamepad, we'll update it. So if it doesn't equal null, which it becomes null because null really means 0. It's a pound define null 0. So, and that happens with this allocate 0. So if it's not null, we have a gamepad attached to it. So then we're going to use those just like we did in the game here. Alright. And we can move these back to here, because I think it looks a little cleaner. And then reuse this. Right, so in order to update, we actually need to pass in the timer, which I've seen some recent articles on the game loop, which I'm considering implementing. I haven't fully decided. It's basically this idea that our elapsed time could vary right now between 12 and 18 milliseconds, or if something really lags behind, it could shoot up to like 200 milliseconds or even worse. And so there's the concept of using a stepped game loop. So you tell it that you want to update 1000 divided by 24. So you're updating 24 frames per second every single second, regardless of what the frame rate is. And then the frame rate would be separated from that update loop in the sense that it can render as often as it wants and just keep maxing it out. But then during that update loop, or during the render loop, you'd try to interpolate between the two frames. So you could be at frame 1 and then be halfway between frame 1 and frame 2, but you don't know what frame 2 is yet, but you still need to render into there. But if you were to render exactly on the updates, you would just be stuck at exactly 24 frames a second, which that's what movies run at, so typically you wouldn't really notice it. But if you've got fast moving objects, especially with motion blur or anything like that, then you would definitely notice it. So I haven't really decided if I want to do that yet or not. And there is another suggestion of lagging a frame behind. So if you know frame 1, but you don't know frame 2, then you step the next frame, and then you know frame 2, but you don't know frame 3, so instead interpolate between frame 1 and frame 2. And so you're always that like 33 milliseconds or whatever behind, which I don't love that idea, but it beats the alternative of having to create methods that predict the future. So it's kind of like saying if you're in a car and you're going 5 miles an hour with an acceleration of another mile an hour, you can kind of decide based on a function where you're going to be in the next frame and get an interpolated value between where you're at in the render. But then you could, like, in that frame have been turning dramatically, and it could cause rendering issues, or like it could clip inside of a wall or something. And granted, those are only a fraction of a second that you'd see it, but I don't love that option either. So we've got our direction. Now we need to update this entity's position just to get it going how we had again. Plus equals direction.x and y. Actually we want the z. so let's get rid of all of this. Back to here, and I don't think we're, yeah, now we're not using the DT anymore, so we can get rid of that. Alright, so we're binding the mesh, doing effect bind. So I think what I'm going to do is do another loop here. And I'm going to assume that this has been set before calling the system render for now, and then it'll change. So when you get to here, I'm going to use this world matrix. Set the world matrix to a translated value of the position of the current entity. And then set it to the world matrix and then render it out. Do character system render, game data, characters. I should be able to get rid of these and rerun this. And hopefully, any movement, no movement. So I did something wrong. Oh, I never called the update. That would do it. So if I do this up the top, and data dot characters, pass in our timer. Alright, I put it in here, but I didn't put it in the header yet. Oops. Alright, so now we should be able to move. Yep, so we're moving, and actually it's like the Y is inverted wrong. But we've got two characters, separate entities using the same system now. So we're a little bit more abstracted. Alright, let's use negative DT. And then come back in here and clean up these. In those positions anymore. I think. Alright, so yeah, that's all we needed to do. Oh, don't need that. And actually, we don't even need the world anymore because that's being used in the system renderer. Good to go. Alright. So, the songs are actually from the Harmony album, which is a whole bunch of Super Smash Bros. Remixes. So that's probably why it sounds very familiar. Alright, so the next bit here. I think I want to start moving this into the scripting system. I'm going to bring back a clear it to black. So now we no longer need our script function for clearing, which is more of a test function anyway. So I'm going to see if I can... Trying to determine how far in I want to go with the scripting yet. So let's say that I created a game wrapper. Let's bring up the scripting here and see what the custom wrapper looks like. Custom wrapper. So what this is going to do is I'm going to have a custom wrapper variable. It's a global one that I can call here. And when the scripting system, when it initializes the script, it'll call this game wrapper. So if I do wrapping the game, and I run this, I should see wrapping the game in the OP log. Wrapping the game right there. So we know that it's being called as soon as the script gets compiled right here. And actually, I added a function because the last time we're compile and run. So it'll run it once. That way we get that. Oh, no overloaded method. Compile and run. No existing content. So that's just. So the context is if you had another script that you'd compiled, you could actually run that script in the same context. So then you get multiple things all attached to each other using the same global variables. Alright, let's do some tests just to see if I can put this wrapper on. Actually, I gotta remember how to even do that. So if we go to, open up the engine, and in here, so these wrappers in here will wrap the entire engine with different functions. So you see render, init, clear, blend. It'll do all these calls, but with the V8 and the Node.js syntax, which gets a little messy. I'm trying to figure out ways to make it cleaner, so then it's not quite as much of a pain to use. Okay, so this is what I want right here. Let's try that. Script value, so we've got our isolate. And so the target here is the global object, so you just kind of like in in the browser world, you've got a window or a global that you can access. Okay, we need to set a name on it, so let's just do test. And then handle value set, so we will need to get script v8 number. Not what we want. Let's go back to the engine. So I've got this helper here that creates a bunch of stuff for us. OP script get value, that's what I want. So that'll convert any value that you give it, which right now I've only got a character array and a float value that you can pass into it. Let's say it is 0.5. Why isn't it happy? Cannot convert argument 4 from a OP script value persistent to a handle value. I'm pretty sure I had a scripting example in here that I can use to compare it against. Bscript get value. Okay, so this might even be the wrong type. Let's see if I can cast this. So what it is there's persistent values and then there's local values. Persistent ones are ones that won't be removed by the garbage collection, whereas the local ones are only meant to be live in the stack of the function that you're running. And as soon as it's done with that, it may or it may not remove them at that point, but it will eventually clear them for the garbage collection, and you should never use them at that point. So what I need to do is change this. I need this script get value to return a handle, like we're doing in the human wrapper stuff here. So I should be able to do that. Let's give it a try. Get number, then we need to pass in the isolate, 0.5, run it, see if it runs or not. Oh. So this is always a pain. V8 engine, when you compile it and run it, does not give very good errors. It's kind of a cannot convert object tempo to an object pointer value, and when you click on it, it doesn't actually tell you where it's at. It's just this random define within the V8 header. So whenever I do this stuff, I tend to compile line by line while I go through and make changes. But it looks like something didn't like this. And it looks like it's probably because of the V8 object. Set value global. So if I do that, it builds. Okay, and to make sure that we got the value, let's go here. We should be able to do, I think it's just test like that. And we'll bring a clear function back in. It did not run. So let's see, it might be global.test. I can't remember if I actually did that or not. No? Okay, so let's see what's being passed in. So in the engine scripting, well, that's the example. So let's go to OP script, require, compile. So right here we are doing global. Okay, custom wrapper, isolate, global. So we are setting it on the global context itself. So test should be a globally accessible value. So why didn't it work? Let's try adding blue in there. Blue worked. So our setting the value did not work. Uncaught, type error, undefined is not a function. Maybe it's OP.print. Just print. There we go. 0. That worked, but our test isn't getting set. might be because it's on the global object itself. Let me try just doing this. Send R test. And in here, we're going to do the same thing that we're doing in the example here. Zero, we only need one value, and values. So we run that, hopefully we give it bright red, and then 0.5 here. Okay. So I can pass in values through that, but it looks like this is a templated V8 object. So I may need to change out the scripting system on when this custom wrapper gets called. The result, context equals new isolate global. Because it's an object template at this point, not the actual context for the global, which is when I want it to be there. So I may need to look into that later and figure out why that's doing that in the engine itself. So I'm going to do that, do a note for that. Okay, so if I can't get the scripting wrapper going yet, let's move on to another task. Let's see where we're at. So we've got two characters running around two different controllers in a batched system. Update. I'm going to clear those out, bring that back. What's next? I think I'm going to go ahead and bring up Magic Voxel and see if I can get a test model in here that's different than the one that we were using. Just try and make, I don't know. Anybody got an idea for something, an object that I can make? So the game, there's a whole bunch of things that it can't be. Like, you can't really have a first-person shooter with a kid playing. You can't really do a racing game, because I want to try to target like between 5 and 10 years old. So I'm hoping for a top-down action-ish story-based game. So it'd be something that's a little bit slower. Pineapple. That's a good one. Actually, I'm colorblind, so I'm not even sure on colors. That's definitely not a yellow. Although I guess technically the outside of pineapple is more of a brownish color, isn't it? Let's make it a little bigger. Maybe not quite that big though. Let's see. Pineapples are kind of got a rounded feel to them. The outside, now it's yellow, okay. It doesn't need to be perfect to be a little test object. I'm trying to get, they've got like a little dip in the center maybe. Actually, I can even bring up a picture of a pineapple. It's two ends. Alright, so they've got some froofiness to them. Alright, so now I do need green, but kind of a darker green. Because I could have just said it was like pineapple slices. Oops. I'm having a hard time using the undo options. So used to using OSX. I'm not really liking that. It's kind of a hard one. Kind of pineapple-y. Let's see if I can get a couple of yellowish things in here. So it's kind of got like a little diamondy pattern thing. It's gonna be awesome when I got multiple pineapples running around the screen. I really do not like that top. It's kind of hard to make it like fan out. A little bit more sparseness to it. Kind of pineapple-y. It's a decent enough test model. It's got enough colors and textures and such to it. Okay, so we'll export an OBJ of that. Bring up Maya. Yeah. Autodesk. Sorry, I have to sign into it every time I start my. Alright, so now we can go and import it. Voxel export, and so now we've got our pineapple. Oh, I forgot to bring it in. Save it, re-export it. Material. Let's add file. Make sure that the color is still on there. Yep. Alright, so now we can export this as an FBX file. Actually, Blender installed? I don't have Blender installed, but I'm going to go ahead and use that. No, we can keep on going with this route. Export all. Pineapple. Bring it into Wayward here. Export all. Back to the engine. I'm going to build. So I've got an FBX to OPengine model converter. Do that in the engine, and then it should pop up under tools so that I can build it and then run it. Tools dot building. So it'll build that when you have to have the FBX SDK installed. Okay. Engine, tools, debug, and there it is. So I should be able to FBX, and our file is pineapple. And we're going to call it pineapple. So we want positions, normals, and UVs. We want the indices, we don't need the function animation and all that. Okay, pineapple.opm, so there's a ton of debug information that I pulled out of these. And it's a huge amount. Oh, that's interesting. Not enough space. Pretty sure I built it alright. Models. And then right now I don't support the Targa file format. I only support PNGs. So I'll have to come in here and convert the Targa file quick. Export pineapple Targa. And I will save that as a PNG. And we'll just save it as pineapple again. Alright, so back to the game. I've put those in Wayward's assets folder. So if I rerun CMake here, it should show up in our solution. Pineapple and pineapple.png. Come up here. We're now going to load up pineapple and use the pineapple texture. See what it does. It loaded it, but it's huge. Alright, let's shrink that down. I think I'm going to do it from here. Scale it on down. Go with 3.25. That's much better. Freeze transformations. Alright. Delete. Delete all by history. Oh, that's not working. Huh. We'll see if it exports alright anyway. There's something goofy about the Maya LT version, the indie one. I'm not a fan of it. I'll have to download Blender and start using that again for the stream. Engine, tools, debug, pineapple.fbx. Place it. Rerun our conversion. Actually, you know what? I'm curious. I've got a web version of this. Tools.OPengine.io. I want to see if I can run it through that or not. Come on. The server it's running on is a little bit slow right now. I need to upgrade it. Alright, so choose file. Wayward. Exported it into the engine's tools directly. So pineapple. No skinning animations or bones. Oh yeah. Our name is going to be pineapple and convert. I should have to probably have a notification in there that it's actually trying to do stuff. Alright, it popped up though. Pineapple.opm. Here. Okay. That didn't work. Why didn't it save it? Oops. Alright. So it should be smaller now. And it's not. Tools, debug, oh. It's still big. I think it has something to do with the fact that it didn't scale here when I exported it. Freeze transformation was not applied because the mesh translate X has an incoming connection. Okay, we're gonna just new scene, don't even save it, re-import the object. Freeze. There we go. That's looking better. I don't know what the deal with that was. Reset. Export all. Tools, debug. Export it as that FBX again, and let's retry it from here. Pineapple, convert. And it should add another line here as soon as it's done. Save link as pineapple. Yes. Okay, now it should be smaller. Pretty sure we got it that time. Yep, that's looking much better. It's still pretty big, but we're 5 units from the screen. So there is another option in Magic of Voxel here. You can change the scale here. And so when I would export the OBJ, it'd already be smaller. I wouldn't even have to deal with that in Maya. So that'll probably be what I'll do from that point forward. But, so now we got pineapples. Thanks to Blue Robin, we've got pineapples roaming around on the screen. Let me go ahead and zoom that out. Camera out, we'll go to 15. There we go, now we got our pineapples going around. The pineapple game, that's what we're gonna make. Alright, well I think that is gonna do it for tonight's stream. I'm going to be back on tomorrow night, and we're going to continue, see if I can get the custom scripting raptor, dinosaur raptors. See if we can get that going and get these characters, get some bounty boxes on them pretty quick here so that they're moving around a little nicer. And then see where we can go from there. Alright, I will see you guys all tomorrow night.